Alright, welcome back to the final exam review for Algebra 2. In this video we're going to cover section 19 where we simplify rational expressions. So, the idea here is that if we have a common factor in a fraction like this, a times b divided by a, if we have this common factor, we can cancel it out and we're just left with whatever the leftover stuff is. So the a's in this case would cancel out and all we have is b. And so we want to use this property to make difficult expressions or more complicated expressions simpler. And that's usually that's to our advantage. We want simpler stuff in math. So let's look at number 253. We have 2b squared plus 2b divided by b plus 1. So in order to answer this question, what we do, or to simplify it, is we try to factor everything as much as possible. So to factor out the numerator here, we ask ourselves, what is the greatest common factor that we have between 2 and 2? Well, that's the number 2. And what's the greatest common factor between b squared and b? And that's going to be 1b. So, since we factored out the greatest common factors, we have 2b, we ask ourselves, well, what 2b times what gets us back to do 2b squared? And that would be b, because 2b times b is 2b squared. And then we ask ourselves, well, 2b times what gets us 2b? Well, 2b and 2b are the same thing, so that has to be a 1. And we can't factor this any further. But now, we divide this by b plus 1 in the denominator. And using this property up here, that if we have a common factor on both the top and bottom of a fraction, we can cancel that out. And so we have this b plus 1 here, and a b plus 1 here. These terms cancel, and we get 2b. And that's it. This is now simplified. So, this is equal to that. Now I want to note that even though this is equal to this, that's not really the whole story here. Because what if I plug in, say, negative 1 into this? So if I plug in negative 1, we have 2 times negative 1, and that's equal to negative 2. Okay, well, that's fine. But if these two things are equal to one another, I should be able to plug in negative 1 over here. And if I do that, I have 2 times negative 1 squared plus 2 times negative 1 divided by negative 1 plus 1. And maybe you see the issue already, but if you don't, that's okay. We have 2 times negative 1 squared, well, that's just 2. And we have 2 times negative 1, which is minus 2. And then we have negative 1 plus 1, which is 0, but 2 minus 2 is 0, and we have 0 divided by 0. And that's a problem, because what is 0 divided by 0? Well, we've been told, or I've told you guys before, that anything of the form a over a is equal to 1. However, that's not the case for a equal to 0, so this actually isn't the whole story here. A can't be equal to 0 for this property to apply. This is called an indeterminate form. Basically, through some algebraic trickery, we can make this equal to whatever we want it to be. And there's different ways you can do that. So there's actually That's why we say that it's indeterminate, because you can't really determine what this value is. If you take a class called Calculus 2 in college, this is probably the first time you'll encounter indeterminate forms. But basically, this and this, sorry, not that. This and this are not equal to one another. If we plug in -1 on this side, we get -2. If we plug in -1 on this side, we get 0 over 0. So because these are not equal to one another, we say that, yes, it's 2b, with the condition that b is not equal to -1. So how do we determine that? Well, basically, anytime you're solving rational expressions, you just try to find everywhere that would make you divide by 0. So we have b plus 1 here in the denominator, and we ask ourselves, where is b plus 1, or b plus 1 can't be equal to 0, and it's like solving an equation. Just because you wrote a is not equal sign here, all you have to do is subtract 1 from this equation to solve it, and we have b is not equal to -1, which is what we have here. So your exam may or may not, depending on which version of the exam you're taking, may or may not ask you to find excluded values. So this right here, it's called an excluded value. But it's worth knowing what this is, and I'm going to find the excluded values for each of these equations, but again, your exam may or may not actually have you do that. So let's look at number 254. So for number 254, thank you. For number 254, we have m squared minus 14m plus 48 divided by m minus 6. So now we want to factor the numerator here and hopefully cancel out a term like we did with the b plus 1 and the b plus 1 over here. So to factor the numerator here, we have to find two numbers that multiply to 48 and add up to -14. So two numbers that do that, let's see, that would be -8 and -6. So we can factor the numerator like this, and we still have m minus 6 on the bottom. And so since we have these common factors of m minus 6 on both the top and bottom, we can cancel them. And all we're left with is m minus 8. And what about the excluded values? Well, we just take whatever the denominator is, and we say, well, m minus 6 can't be equal 0. If it's equal to 0, if m minus 6 is equal to 0, then we divide by 0, and we can't do that. That's why we ran into an issue up here. So we solve, well, m minus 6 can't be equal to 0, so what does that mean? If we solve for m, that means m can't be equal to 6 if we add 6 to both sides. So this is our final answer. So all of this is equal to m minus 8 with the condition that m is not equal to 6. And this is our final answer. What about the next one? We have 255. We have p squared plus 3p minus 70 divided by p minus 7. So let's factor the numerator. Well, what are two numbers that multiply to -70 and add up to +3? let's see. Well, since we have a p minus 7 down here, that kind of gives us a hint of what the other number has to be. So if negative 7 is one of our numbers, whatever number you add to negative 7 to get 3, that's going to be positive 10. And sure enough, p minus 7 times p plus 10, negative 7 and positive 10 multiply to negative 70, and negative 7 plus 10 is equal to positive 3. So we have a common factor of p minus 7 on both sides. We cancel that. We say that this is equal to p plus 10. But what about our excluded values? Well, p minus 7 can't be equal to 0. So we write that p minus 7 can't be equal to 0. And solving for p, we just have to add 7 to both sides. And we get p can't be equal to 7. And so, this is our final answer. So all of this is equal to p plus 10, and we say that with the condition that p can't be equal to 7, because, again, if we plug in 7 over here, we have 7 minus 7, which is dividing by 0, and we can't do that. And it looks like the smiley face persisted on the other side too. All right, so we have 256. This is v squared plus 4v minus 45 divided by v minus 5. So let's find two numbers that multiply to negative 45 but add up to 4. And if we think about those two numbers, well, negative 5 is probably going to be one of them. And, well, if we have 9, negative 5 times 9 is negative 45, negative 5 times, or plus 9 is 4. So we have v minus 5 times v plus 9, all divided by v minus 5. We have common factors of v minus 5, so that cancels, and this is equal to v plus 9. But what is our excluded value? Well, we can't divide by 0, so we say that v minus 5 can't be equal to 0. And adding 5 to both sides of this equation, we get v cannot be equal to positive 5. So 5 is our excluded value. V can't be equal to 5. And so all of this is equal to v plus 9, with the condition that v can't be equal to 5. What about one like number 257? With 257, we have 6k squared plus 8k divided by 6k. Well, let's find the greatest common factor between 6 and 8. And the greatest common factor we have is 2. And now let's find the greatest common factor between k squared and k. That would be k. And so we got to find 2k times what gives us this again. So, well, 2k times what gives us 6k squared. So, let's see, 2 times what gives us 6. Well, that's a 3. And then k times what gives us k squared. That's going to be a k. And let's see if that makes sense. We have 2 times 3 is 6. K times k is k squared. So 2k times 3k is 6k squared. And I'm going to make this a little bit more spaced out. And now we just need to ask ourselves, well, 2k times what gives us 8k? Well, 2 times 4 gives us 8. And, well, k times 1 gives us k, so we don't even need to write anything else. So we just have 3k plus 4. And now all of that is divided by 6k. And now let's see if we can factor out, or we cancel out any common factors. Well, we have 2 over 6 right here, and if we think about what 2 over 6 is, that's just equal to 1/3. So, how we could write that is we don't write the 1 in a numerator if we have other stuff. Now, in a fraction like this, we need the 1. However, if we had something like this, maybe like 2k divided by 6, if we cancel this out, the 2 and the 6 into 1/3, we wouldn't write the 1 there. We'd just have k over 3. And so that's what's going to happen here. However, we also have a k and a k. The k's cancel out because they're common factors. And so really, we just have 3k plus 4 divided by 3. So 2 over 6 gave us 1/3. K over k canceled out the k's, and then we were just left with 3k plus 4 over that 3 from the 2 over 6, which gave us again 1/3. So we have 3k plus 4 all over 3. And now we just need to find our excluded values. Well, we can't divide by 0, so 6k cannot be equal to 0. And so to solve this equation for k, divide by 6 on both sides, and we still have that k can't be equal to 0. So all of this, the 6k squared plus 8k divided by 6k, is equal to 3k plus 4 divided by 3, with the condition that k can't be equal to 0. Keep the smiley face in view. What about number 258? We have a squared minus 2a minus 63, all divided by a minus 9. Alright, so we're factoring a quadratic here. Let's find two numbers that multiply to negative 63, but add up to negative 2. This a minus 9 gives us a hint as to what we might be trying to cancel. And so we have negative 9 and positive 7. Does that work? Well, negative 9 plus 7 is equal to negative 2. So we have a minus 9 times a plus 7, all divided by a minus 9. We have common factors of a minus 9, so that cancels, and we have a plus 7. And now we find our excluded values. We know that we can't divide by 0, so we have a minus 9 can't be equal to 0. And adding 9 to both sides, we have a cannot be equal to 9. And so that is our excluded value. Now let's look at number 256 or 259. For number 259, we have n squared plus 3n minus 18 all over 7n minus 21. So we want to factor everything completely. Let's start with the numerator. We want to find two numbers that multiply to negative 18 and add up to 3. Well, two numbers that do that, let's see, we have 6 and 3, and it looks like we need a negative 3. So we have n plus 6 times n minus 3, and sure enough, 6 times negative 3 is negative 18, and 6 minus 3 is positive 3. What about the denominator? Well, the greatest common factor between 7 and 21 is 7. But 7 times what gives us 7n minus 21? Well, 7 times n gives us 7n, and 7 times negative 3 gives us negative 21. And now we have these common factors of n minus 3. We can cancel those, and all we're left with is n plus 6 divided by 7. And so we want to find our excluded values. Now we can start over here and we can solve this equation, or we can actually start over here. And we actually have the zero product property that we can use, and that basically means that, remember, that's that if we have a times b is equal to 0, then a is equal to 0 or b is equal to 0. Well, 7 times all of this can't be equal to 0, so it doesn't really make sense to say that that's equal to 0, but we do have this n minus 3 can't be equal to 0. So, really all we have to do is flip the sign on this, and we have n can't be equal to 3. Now we could explicitly solve this over here as well, but we already factored it, and it kind of makes our lives easier. So when you get to the step of everything being factored, I recommend looking for your excluded values in that step. In the previous problems, the denominator was already factored, so we didn't have to worry about that. But when we get to this step where everything's already factored, this is where I recommend trying to find your excluded values. But we have that all of this is equal to n plus 6 over 7, with the condition that n can't be equal to 3. And so that is our final answer. Let's look at the next one. For number 260, we have 10m plus 30 divided by m squared minus 9. So let's factor the numerator. Greatest common factor between 10 and 30 is 10. And we don't have any greatest common factors between m and no m, so it's just 10 that we can pull out of this. So 10 times what gives us 10m? That would be m. And then 10 times what gives us 30? Well, that'd be positive 3. So the top is factored, and now we want to factor m squared minus 9. We want to recall that the difference of cubes formula tells us that if we have something like a squared minus b squared, that it's equal to a minus b times a plus b. Well, 9 we can write as 3 squared, so I write this as m minus 9. This is equal to, maybe I'll write it below, that way you can see it in line with the difference of cubes formula. This is equal to m squared minus 3 squared. And so all we have to do is we recognize that in this case a is m and b is 3. So we have a minus b, so m minus 3, times a plus b, so m plus 3. And so that means that we can factor m squared minus 9 as m minus 3 times m plus 3. And now we can factor out, or we can cancel these common factors of m plus 3. That leaves us with 10 over m minus 3. But we got to find our excluded values. So with m minus 3 and m plus 3, this is already factored for us. So all we have to do is flip the signs. We say that m minus 3 can't be equal to 0, and m plus 3 can't be equal to 0, because this is already factored. And so that just means that m can't be equal to positive 3, and m can't be equal to negative 3. So we have two excluded values. And there's actually two different ways we can write this. We can say that m can't be equal to 3, and m can't be equal to negative 3, or there's a kind of a more compact way that we can do that. We can say that m can't be an element of the set negative 3, comma 3. It doesn't matter which order you write those, but this is convenient for saying maybe a list of stuff. So maybe we had like 3, 4, or even 10 excluded values. It may be kind of tedious to write out, well, m can't be equal to this, m can't be equal to that, m can't be equal to that, and list off a bunch of other things. With this notation, m is not an element of, and then listing a set of all those numbers, it's kind of a more compact way of writing the same idea. So we just have that that all of this is equal to 10 over m minus 3, with the condition that m can't be equal to negative 3 or 3. Okay, and let's look at number 261. So we have 7n minus 14 divided by, wow, I really botched that one, n squared minus 4n plus 4. So let's factor the numerator first. The greatest common factor between 7 and 14 is 7. And now, again, we can't factor out an n or anything because this term doesn't have an n. Now we want to figure out 7 times what gives us 7n? Well, n, because 7 times n is 7n. And then 7 times what gives us negative 14? That'd be 7 times negative 2 gives us negative 14. What about the denominator here? Well, we're going to factor this as we find two numbers that multiply to 2 but add up to negative 2. And that would be negative 2 and negative 2. Negative 2 times negative 2 is positive 4, but negative 2 minus 2 is negative 4. So now we cancel out our common factors of n minus 2, and we have that this is equal to 7 over n minus 2. Well, this looks good. Now we just have to find our excluded values. And our excluded values are going to be given by whatever these are in our factored form. Fortunately, both of these are n minus 2, so we only have to solve one of them. But we have that n minus 2 can't be equal to 0. Therefore, n can't be equal to positive 2 if we add 2 to both sides. And so our excluded value is that n can't be equal to 2. And this is now factored. What about number 262? We have 2k cubed minus 10k squared divided by k squared minus 25. All right. Well, let's find the greatest common factor between 2 and negative 10. That would be a positive 2. And what about the greatest common factor between k cubed and k squared? Well, this is 3k's over here. We have another 2 over here. So the greatest number of k's that we can pull out is 2 of them, so we have k squared that we can pull out. And now we ask ourselves, well, 2k squared times what gives us 2k cubed? Well, if we multiply that by k again, we have 2k squared times k, so now we have 3k's, and that gives us the k cubed. What about over here? Well, we have 2k squared times what gives us negative 10k squared? Well, we have k squared and k squared here, so we don't have to multiply by k anymore. but 2 times what gives us negative 10, that would be negative 5. Because 2 times negative 5 is negative 10. So this is canceled, or sorry, this is factored. And now we just have to factor k squared minus 25. Now the short way to do this is that if you have a variable squared minus a number, is you can write this as, we're going to have two k's at the front. One's going to be minus, one's going to be plus. And what's the square root of 25? That's 5. So we have k minus 5 times k plus 5. And so we have common factors of k minus 5. Those cancel. And we have 2k squared divided by k plus 5. And now we just have to find our excluded values. Well, from here, we have that k minus 5 can't be equal to 0. And we have that k plus 5 can't be equal to 0. So, adding 5 to both sides, k can't be equal to 5. And subtracting 5 from both sides, we have that k can't be equal to negative 5. So, we can either say that k is not equal to 5 and k is not equal to negative 5, or we can say that k is not an element of negative 5, comma 5. And so, shorter notation for conveying the same idea. And there we go. So, all of this is equal to that, with the condition that k can't be equal to negative 5 or 5. Let's look at the last two. For 263, we have n squared plus 13n plus 42 divided by n squared plus 4n minus 12. So let's factor both the top and bottom. Let's find two numbers that multiply to 42 but add up to 13. So let's see, we have 6 and 7. So we have n plus 6 times n plus 7. And for the bottom, we want to find two numbers that multiply to negative 12 but add up to positive 4. So let's see, we have positive 6 and negative 2. And now we have n plus 6's on both the top and bottom, so those cancel, and all we're left with is n plus 7 divided by n minus 2. So you're probably not recognizing a pattern with these excluded values. You basically just have to flip the signs on whatever these are. So like if this is a negative 5, this is going to be a positive 5. This is a positive 5, so this turns into a negative 5. And over here, this is a positive 6, so n can't be equal to negative 6. And over here, n minus 2, n can't be equal to positive 2. And so our excluded values, n can't be an element of negative 6, comma 2. And so these are our excluded values, and all of this is equal to that, provided that n can't be equal to negative 6 or 2. For the last one, for 264, we have x squared minus 4 divided by 2x plus 4. So, factoring the top, we have our difference of squares formula. We have a variable squared minus a number, which means that we can factor it as x minus x plus, and whatever the square root of 4 is, and that's 2. So x minus 2 times x plus 2. And then, factoring the denominator, the greatest common factor between 2 and 4 is 2. We can't pull out any variables since this term doesn't have a variable. And then 2 times what gives us 2x, x, because 2 times x is 2x. And then 2 times what gives us 4? Well, 2 times 2 gives us 4. And so this is now factored, and we have these common factors of x plus 2, so those cancel. Now all we have is x minus 2 divided by 2. And so, excluded values, this was a plus 2, and x cannot be equal to negative 2. And so this is our only excluded value. And so this is our final answer. And so that concludes this video. So thank you for watching.